Hi, this video will show how the Keptn Job Executor can be used to run any container. The other way to trigger tools from Keptn is via webhook. I'll link to this video above. The Job Executor Service is a Swiss Army knife for Keptn. It can run any container as a Kubernetes job. Therefore, it can also run Python, PowerShell, or shell scripts. The Job Executor will first be used to run a pre-built container, and then the demo will be expanded to run a custom-made Python script. A tool called infracost provides cloud cost estimates based on Terraform plans. We want to integrate this cost data into the data-driven SRE decisions that Keptn makes. In other words, if the infrastructure is an acceptable cost, allow the deployment. If the infrastructure is too expensive, block the deployment. Start by installing the Job Executor Service on a control plane cluster, or a remote cluster, also known as an execution plane cluster. This Keptn project has two stages, dev pre-check and dev deploy. The dev pre-check stage has one sequence with a task called check cost. The Job Executor Service will be configured to run the infracost container in response to the check cost triggered event. Keptn will automatically trigger the deploy sequence in the dev deploy stage on successful completion of the check sequence in dev pre-check. In other words, when infracost is finished, the deployment will automatically begin. The Job Executor Service requires a configuration file telling it what to do when it hears an event. Here, the Job Executor Service is configured to listen for the checkCost.triggered event. When that event is heard, a Kubernetes job is created based on the infracost CI image. A Kubernetes secret has already been created in the same namespace as the Job Executor Service, and we reference that secret to make it available to the job. The secret holds the infracost API key. The Job Executor Service also takes files from the files folder stored in Git and copies them into the job pod. These are available under the /Keptn folder. Finally, the job is executed with the command on lines 14 to 18. Let's trigger a new sequence now and watch what happens. Infracost runs successfully and the deployment sequence in the following stage is automatically triggered. Notice for demo purposes, here I'm doing a Helm list all rather than a Helm deployment, but the principle is the same. This logic isn't very smart. Every deployment occurs regardless of the infracost cost result. This is where Keptn can add value. We will use Keptn to drive decisions based on data, that is the infracost result, to decide whether or not we allow the deployment to proceed. To do this, we first need to push the infracost metrics to a backend. In this case, Prometheus is used. The infracost image has no way of exporting metrics, so instead, a Python script will run infracost and then push metrics to Prometheus. We also need to adjust the job config file so that the Job Executor Service runs the Python script instead of the standard infracost image. Add a new evaluation task to the shipyard. Keptn already comes with microservices capable of handling this task. When the Python script completes, Keptn will trigger the evaluation task. Metrics will be retrieved from Prometheus and the quality gate will be evaluated. In this case, the quality gate result is a pass because the metrics are acceptable. That is, the deployment cost is acceptable, and so the deployment proceeds. Imagine a developer changes something in the infrastructure. Here, we will upgrade from an M5 4x large to an M5 8x large instance, causing an increase in cost. We have already defined a service level objective whereby this increase is unacceptable, and so the evaluation result will be a failure. The deployment is blocked. Keptn has automatically prevented a very expensive deployment from occurring. The Keptn Prometheus service was installed on the cluster. This service contains the logic of how to interact with Prometheus and retrieve metrics. Then we added two files, an sli.yaml file and an slo.yaml file. The sli file defines the indicators that we may want to pull from Prometheus. Notice they are defined in Prometheus syntax. The SLO file takes these indicators and provides the objectives, or thresholds that Keptn will use during the evaluation task. So there you have it, an overview of the Job Executor Service plus how it can be used with an arbitrary container like infracost to make data-driven decisions. I hope you found this useful. Thanks for watching.